Hi everyone, so today we'll take a look at isotonic, hypertonic, and hypotonic solutions. So what happens when a cell, a bacterial cell, it might be another cell, if they get subjected to any of these three types of osmotic solutions. So when is the isotonic? There is the hypotonic, and the last one is the hypertonic. So just by the name, you can all grasp that iso means equal. So basically, the isotonic solutions are the one in which there is equal amount of solute both inside the cell and outside the cell. It can be a solution where the cell is placed. So basically, I just suppose that this is a glass of water. Okay, and there's like water in it. And just suppose that this is a cell placed in a water, cell placed in a water, cell, water. So in the isotonic solutions, the cell has an equal amount of, there's an equilibrium inside the cell and outside the cell. The solution in which it is placed in equal amount of solute. Equal amount of solute. Just remember that it is the amount of solute we're taking a look at, not the amount of water or any other thing, the amount of solute. So there's an equal concentration of solute. Three molecules here, three here, equal. Okay, and so a cell is basically stable in an isotonic solution. So what? This is an isotonic. Okay, so the next one we'll take a look at is the hypotonic. So by the name, you know that hypo means less. Okay, so it means less solute. But the question is where? Inside the cell or outside the cell? Well, like what thing we're looking at? Where is the less solute in? So basically, in the hypotonic solution, the solution, as the name says, solution, hypotonic. This solution has a less amount of solute. So basically, if this is a glass of water, yeah, and the water literally has a less amount of solute, but the cell has a higher amount of solute as compared to the solution. So this is a hypotonic solution. So in this one, what will happen? So let me just mention less solute, high solute. And in this solute is equal in cell is equal to solute in outside. Okay. So what will happen when a cell is placed in an hypotonic solution? When the water, so in a hypotonic solution, basically the water, as we've discussed in osmosis, which is the net movement of water from a place of less solute concentration to a place of higher solute concentration. Just remember that this is the solute we're talking about. So what will happen in a hypotonic solution? The water will basically enter the cell to a place of higher solute concentration, okay? Just remember this point. This is very important. Let me just write it in a more neat way. Okay. So in a hypotonic solution, I've just said that the water will, so I'm making this a cell, another cell, okay? It has more higher amount of solute than its environment. So basically, just suppose that it's in a water where there is literally less amount of solute. So the water will enter the cell, and what will happen to the cell? The cell wall will become swelled. And what will happen when the cell wall is swelled? The cell will basically burst due to all that water accumulated in this. If the cell, basically one function of cell wall is to protect the cell from osmotic lysis. So if the cell wall is weakened, if a cell wall is weak, if a cell wall is weak, so basically the cell wall will become swelled and it will be destroyed, and the cell can no longer prevent the osmotic lysis and it will burst. So the cell will burst if a weak cell wall is present. Okay, so this is the hypertonic solution when a cell is placed in an hypotonic solution. So the last one we'll take a look at is the hypertonic solution, which is the opposite of the hypotonic solution, as the name is already suggesting that hyper means more. Hyper means more. Hyper means more solute in the solution, not inside the cell. As this is this hypertonic solution, so the solution will contain the more amount of solute. Okay, so just imagine that. Again, I'm gonna make a bowl of water. Okay, so just suppose that this is water all inside the water all inside the this bowl. Okay, I'm sorry, that's messy. Okay, and there is a cell placed in this water. Okay, this is the nucleus, this is the DNA. Okay, so what will happen? So this is one of the most important point. Okay, so this cell has a lower amount of solute than the outside, lower, and but the solution has an amount of more solute relative to the cell. So what will happen? Cell also has many water. Okay, so what will happen? Basically, what will happen is that the sorry. So let me just show it the bigger version here. So this is the same cell. This is cell. Okay, this cell. What will happen? So due to the less amount of solute inside the cell, the water from the cell and the higher amount of solute outside the cell in the solution, the water from inside the cell will move out to the higher solute concentration. Okay, so the cell has a low solute and the outside has a higher solute concentration. So the water from the cell will move outside. Water moves out of cell. And what will happen? The cell will lose excessive water. The cell will lose many water, and due to which what will happen? It will lose water and it will get basically it will get shrinked up. It can get like that. It's shrinked cytoplasm due to excessive loss of water. The cell will get shrinked, and as a result, the cell will die.